So, yeah, my name is Felix Polyudov. I work at AMI, and I would like to present a couple of things that are going on at the Open Platform Firmware project, which is part of the Open Compute project. Like, I guess most of the people familiar with the Open Compute, that's like an industry organization that mostly focuses on addressing various issues in the data center area. There are different sub-projects like hardware, manageability, so Open Firmware is one of the sub-projects. So I guess I would like to explain in a few words why we are even discussing this. After all, this is UEFI Developers Conference, not an OCP conference. So there are two reasons. First, both like UEFI and OPF, these are essential organizations that are trying to address issues in the area of platform firmware, system firmware. So a lot of problems that people are trying to solve are kind of similar. So I believe both organizations can benefit from kind of cross-pollination, from expressing different opinions or feedbacks to each other. And then second, if this open platform effort succeeds, we are going to have a couple of new specifications, and they will have some effect on the UEFI ecosystem. So I'm trying to present what could be the impact, what needs to be done from the UEFI side to get in alignment. So I think last year, this open platform firmware project in OCP was kind of reloaded, restarted. It was dormant for a while, and now there are two active work streams. The Open Silicon Firmware Interface work stream and the UEFI Platform Configuration Interface. So the first one attempts to define a unified interface between the silicon portion of the firmware and the kind of the rest of it, the generic part, the platform part. And then the second work stream tries to simplify platform configuration. Just a picture to illustrate what we are trying to do. So of course the UEFI is essentially an interface specification which defines an interface between operating system and firmware. So in a way, system firmware from pure UEFI point of view is a black box that, and then the spec defines the UEFI services, protocols, and then tables such as like UEFI system tables, ACPI, SMBIAS, to provide interface between OS and firmware. Now, we also have the PI specification, which defines details on how, of one possible implementation of the UEFI specification. And that's, of course, becomes more complicated. There is Dixie Foundation architectural protocols. Then, of course, the data tables is published by the corresponding drivers. And, of course, all the modules have to interact in a certain way. Some of the interfaces are defined by the spec, like, for example, the ACPI driver publishes the ACPI table protocol, which is part of the PI spec. But then, of course, some of the interfaces are proprietary. And conceptually, we can split the variety of drivers in the UEFI firmware to three large groups. The generic drivers, which are not hardware specific, for example, like a partition driver, or even the ACPI driver that publishes ACPI protocol. The silicon specific drivers that are typically coming from the silicon vendor, and then the platform drivers, which typically come from the firmware owner, the IBV maybe, or OEM, ODM. And of course, this is a simplification. So in reality, there is more complexity. There is PI phase, there is MM, like runtime. So if I have to explain in a couple of words what like OPF is trying to do. We're trying to simplify the system firmware to a certain degree. So what is the like vision? I mean, OPF vision, but in fact, of course, OPF is not operating in terms of UEFI. They trying to apply that to any kind of system firmware. So it's kind of my interpretation on how it may apply to the UEFI firmware. So as I said, there are two work streams. So the OPF work stream, OpenSFI work stream tries to standardize interface between the silicon initialization code and like the rest of the firmware. So essentially, where we now have like platform-specific drivers, where we have to have like different wrappers for example, for Intel, for AMD, for ARM, for different silicon vendors. Or even oftentimes we have to go change those wrappers even, when we transition from generation to generation with the same silicon vendor. The goal is to maybe to reduce that porting effort and try to come up with a standardized interface that essentially can be used for any silicon vendors. And then the platform configuration workstream tries to simplify the process of configuring the platform. We'll have some additional details in the further slides. Maybe I'll just briefly mention that in a way, in the UEFI world, we have several sources of configuration information, like the UEFI variables, the PCDs, the HI, and all of them are used like interchangeably. So the idea is to try to maybe normalize, to simplify the process of platform configuration. So now let's look at each work stream. So Open Silicon Firmware Interface. So actually, both of the work streams are currently at the conceptual level. Like there is a 0.3 specification, OpenSFI specification, but this is like an architectural overview, maybe like a very high level draft that maybe describes the goals, the intentions, provides the high-level API, but it's at this point it's not yet implementable. It's a work in progress. That's why it may change, but at the same time, I think this is kind of the right time to present it here because we are still pretty much open for feedback. So if you want to influence, you can influence because that's OPF is also open organization. Anybody can join. So, as I mentioned, the key goal of the Open Silicon Firmware interface to streamline firmware implementation by defining interface between host firmware and the silicon initialization code. And of course, this is not the first attempt, and this is a noble cause, but a challenging one. So, in an attempt not to fail, we are trying to start like with a simple interface. Then maybe because probably it's very easy to get lost in addressing details. So maybe if we can step gradually, like for example, we reduce amount of silicon-specific code by, I don't know, by 5%, maybe by 10%, maybe, and see how far we can go. So currently the interface just has two functions: initialize silicon and execute silicon runtime operations. So the function interface is pretty basic. The input parameter, output parameter, execution stage, and then like silicon ID. Now there are some ongoing discussion whether the silicon ID should be an input parameter or the silicon code should auto-detect it, so that may change, but this is how it looks like at the current level. So essentially the idea is this function is going to be called multiple times for different stages, like sequentially just progressing through the boot flow. There is the initialization stage is an enumeration that is defined here. Most likely that's not the final, list of stages. So that's the work that will be done in the process of defining like 0.5, 0.8 versions of the specifications. Now, if you notice, the input and output parameters avoid pointers. And like to me as an firmware vendor, that's not very helpful, because in a sense, if that definition is different for every silicon vendor, it's not helping me. I still need to have a separate implementation for every silicon vendor. So the goal is to come up with a specific data structure to represent input and output parameters. But it's just, we are not there yet. And again, it's probably difficult to, or maybe impossible to come up with a 100% generic interface, but maybe it will be some combination if we can have like a standard part and then maybe a vendor-specific portion, something like that. Like, for example, if I can make this function call and use standard parameters to generate like SM bias tables for CPU and memory, there is already value in that interface. And so that's kind of the practical approach, maybe moving bit by bit to see how far we can go. The second function has exactly the same interface. Kind of the key difference, the initialized silicon is supposed to be called one time for every stage. And then if there are some like repetitive operations, such as maybe telemetry, like reconfiguration, that will be handled by that second function. Now, what may be impact on the UEFI specification if this spec, becomes a reality? So, in my opinion, like a couple of areas we need to pay attention to. First, this open silicon work stream is currently focused on creating a library, essentially, like a source-to-source interface. Whereas in UEFI, our level of abstraction is higher. We're typically talking about binary-to-binary interface. We have this nice chapter 2, which defines calling conventions for all the architecture. So, and we probably wouldn't want to lose that ability. So there is a kind of easy way to achieve it by defining like a protocol PPI interfaces which serve as wrappers for the OpenSFI library. And that way, and then we can reuse the UEFI ABI for all the CPU architectures and kind of retain the same level of abstraction. Of course, for that we have to make sure like OpenSFI is not adopting some incompatible like calling conventions. But I think there are enough parties interested in that, so I think it's going to happen. And then, of course, I just showed those initialization stages that OpenSFI is dealing with. So what those stages mean in terms of like PI control flow. I mean, this is just I try to do some mapping, but of course, as more details is available from the OpenSFI, we'll have to see, how they align with the boot flow of the UEFI, or rather PI system. And then maybe at some point we'll need to develop some, like a white paper or something that explains like how to implement OpenSFI with UEFI firmware. So this is as far as the OpenSFI. The platform configuration interface. So as I said, the key goal is to simplify platform customization process. In a way, today, generic code are largely coming from the open source implementation. This reference code comes from silicon vendors. So platform code is where like platform vendors, firmware vendors spend the bulk of their time. And right now, so we're trying to reduce that effort and maybe simplify the process, the increased amount of code that can be reused. Like right now, for example, sometimes we are exposing the same data, but different architectures ask for a different standard. So maybe you have to implement the same thing using like ACPI, device tree, maybe some other proprietary interfaces. And oftentimes it's three different like branches that are not, that we have to maintain. So the goal is to try to, maybe simplify that process. I'll explain how. Now let's briefly define what I'm calling platform configuration. So essentially, everything that changes from platform to platform. For example, the SoC configuration, which is essentially an input to this OpenSFI interface, so all kinds of silicon policies. The layout of the boards, maybe information about buses that are not auto-enumerable, such as I2C or SPI, information about peripherals, like TPM, embedded controllers, maybe Super I/O that cannot be auto-detected. And then the board layout, like number of slots, like DIMM slots, PCI slot, like I/O ports. The board information that typically goes to SMBIAS tables, for example, manufacturers, system ID, etc. And even the firmware policies, something that you typically find maybe in a setup. Now, what's the approach? How we are trying to address that? So UPCI is a data interface. So we are trying to define essentially a schema for the configuration information. Focusing on data interface, makes it simpler. We don't have to deal with the programming language dependencies, the execution environments, or even the specific firmware architecture. And also, it simplifies the process. You don't need essentially a programmer. You can potentially, even some like technician can do that change from one platform to another platform. So we are trying to, there are two classes of problems. We are trying to make it simpler at runtime when firmware is running. So we are talking about some binary level presentation for the data. And we are trying to simplify development process. Hence, we are talking about like the human readable representation and machine readable representation. Or if you want like a source format and a binary format. So the human readable representation is supposed to like facilitate multi-vendor collaboration, because today, for example, when we receive like the board configuration from our vendors, sometimes we get an Excel spreadsheet, sometimes we get a C code, sometimes we get an email or a zip file. So maybe on a line on a format we can simplify that problem. Then, as I said, hopefully the platform customization will be easier, because it will be easier to reuse. For example, maybe your like TPM configuration, you have a product family based on different silicon vendors, but you implement similar feature set on all of them. So today, even if you use the same peripheral devices on multiple boards, it's difficult to reuse that configuration information for those peripheral devices. So the goal is to enable that scenario. And then, of course, the hope is that this format will be precise enough to enable creation of a tooling on top of it. So the binary representation, the hope is that it will become like a single source of platform configuration. So I've mentioned already several times that the goal is try to remove redundancy, remove like necessity to essentially present the same information in different formats multiple times in the same firmware image. So our work in like UCPI work stream essentially involves several parallel efforts. As I said, we are trying to define the human readable and machine readable representations, which is essentially a UPCI framework. So it's kind of a schema that defines how to encode the data, how to describe the data. And then we are trying to leverage that framework to define data structures for the key configuration areas. Like one focus area is maybe input, output of the OpenSFI specification. Then, will be kind of discuss several areas that seems to be of high interest, maybe like CPU configuration, memory configuration, PCI Express, etc. Now, we're not trying to replace any existing standards. So this effort is about simplifying the implementation, which means the key for this UPCI infrastructure, it should align with the existing industry standards. And there are two ways. Like, first, maybe sometimes we can directly adopt data formats used by other specifications. Like, then that's the easiest way to align. But in many cases, it will not be possible. In these cases, we are envisioning some standard export procedure. So, like today, you can often see a code that, for example, calls get variable or get PCD, and then there is a bunch of assignments. Okay, let me build a CPI table. This field is coming from this field of this variable. The other field comes from another variables, and the third field, maybe I have to make a protocol call. So instead, how we are envisioning it, that you can have a schema for the UPCI data structure, schema for your target data structure, like maybe like a CPI table, and then generic code that will do data structure transformation from one schema to another. Kind of similar to, there is like this XML transformation specification. Of course, I'm not saying we'll use that. I'm saying that's the same principle, the same idea. Now let's go back to UEFI world. So how we are doing configuration in UEFI? There are several mechanisms. The UEFI variables, which is just abstract data storage interface. There are PCD tokens, which can be persistent and thus can be used for storing configuration. And then we have an HI infrastructure, mainly the storage or an extraction protocol is a configure routing protocols. And also, sometimes there are policy protocols, which is just data-only protocols. So that's, of course, is very flexible, but very complicated and makes development, it's very difficult to, for example, create a universal tool that performs configuration migration. And there is also, as I've mentioned, any kind of export to a different industry format has to be done manually. So this is the problem that we are trying to address. Now, what is the impact on the specification and maybe the implementation of the UEFI firmware? As I said, the OPF is focusing on a data-only interface, but of course it doesn't mean that there should not be programmatic interface. So once the spec is mature, I think it makes sense to create a standard UEFI interface to access the data. And then maybe integrate it with the HI infrastructure by creating a new IFR varstore type that can be used to directly deal with the UPCI data structure. On the implementation side, I'm seeing a few potential benefits. Like right now we have a couple of packages, the dynamic tables package and the Redfish client package, which essentially deal with that problem that I said. They take like UEFI data and publish industry standard data structures defined by another industry standard. So I think that would be a good indicator of a measure of success of UPCI. If we can simplify those two packages, if they can become, if amount of porting, if these packages can be reduced, that will be one measure of success. Now, I mentioned on the previous slide, there are many ways to get configuration in UEFI. The hope is maybe in the long term, UEFI drivers, PIMs can use this UPCI interface to get the configuration data. But also, there is a niche, all the interfaces that I mentioned, UEFI interfaces, they're there for a reason. There is a niche to keep using them. So we are not, again, we are not planning to replace, we are planning to provide a way. For example, if you want to keep using HAI, that's fine, you can keep using HAI. There will be, for example, config access implementation that can, interact with UPCI. So this is like a very high level, high level overview. So we don't have, I think we have a couple of minutes, right, for at least for one or two, yeah.
So why would this belong in the UEFI spec and not in the PI spec? Is it because of the third-party drivers, or is the OS supposed to consume any of this?
You're right. It's probably better fit for PI, but I think we'll see if you need to expose it to UEFI. But I think you're right. Yes, PI is a better fit.
So first off, thank you for trying to teach hardware people about software engineering. Like, start with a data model, don't start writing code. That's awesome. But the other thing I thought about when watching your presentation, especially with like the presentation yesterday about Go, bare metal Go, is, if you look at this from an OS point of view or embedded firmware point of view, like kind of what you might want for the Dixie core is like a how that abstracts, some of the architectural protocols that are the hardware abstractions that are required for things to work. So would you guys consider like not just silicon and NIT, but some basic functionality things? So like basically you could have a shim that the Go presentation from yesterday could plug into, right, generically. And then your blob could just work with that. We could have like, a Dixie architectural protocol how that would plug into it, provide some of the architectural protocols. And just, to sort of give you a basic level of functionality for any given piece of silicon.
Yeah, I think it's a good idea. Maybe, as I said, right now the main challenge to get it going. So at this level, it's very basic. But yeah, at some level, I think yes, it's also a good idea to try to work on something like that. Yeah.